Okay, to start our unit on gases, gases are all around us. You can see our skydiver leaping into the Earth in our Earth's atmosphere, which is a mixture of gases. We use gases for hot air balloons. We use gases for balloon flights around the world. They have lots of uses in everyday life. So some properties of gases are they will expand to fill and take the shape of the container. They are low in density, compressible. Mixtures are always homogeneous, and they are also said to be fluid, meaning that they flow easily. Pressure, as in gas pressure, is a total force applied to a certain area. The larger the force, the larger the pressure. The smaller the area, the larger the pressure. Gas molecules will collide with the container or a surface, where more forceful collisions or more frequent collisions result in higher gas pressures. We're going to be looking at units used for gases, specifically gas pressures, and we're going to be looking at some conversions that go with these. So our typical unit that we use are atmospheres or millimeters of mercury. Millimeters of mercury can also be expressed in torrs. Sometimes you'll see pascals used as well, and kilopascals. So I've circled some of the main conversions that we would want to be using in class. Inches mercury and the PSIs are more everyday units that you might see, but we usually don't use them in our chemistry classes. We do need to know how to convert between the units. For example, for pressure conversions, we have a mercury column that is found to be 732 millimeters. So that would mean that it has a pressure reading of 732 millimeters of mercury. So I set up a conversion here where we have 732 millimeters of mercury. And remember, when you set up your problems, you want to set them up so that your units would cancel out, leaving you with 0.963 ATMs. Now for our second conversion here, so we did ATMs. For our second conversion, there really isn't a conversion because a millimeter of mercury is the same as a torr. And then for the pascals, we would just need to go back and use our conversion, and we can actually use the 760 torrs, or in this case millimeters of mercury, equals 101,325 PAs, where all of these are equivalent to each other. So I set up my work with my 732 millimeters of mercury outside, the parentheses, my conversion inside the parentheses, they'll cancel out to give us 97,600 pascals. And of course I kept 3 sig figs in the answer because I started with 3 sig figs. So some additional problems for that, you might see the original pressures given in scientific notation. Make sure you remember to use on your calculator, make sure you remember to use the EE button. I know this is probably small in the video, but make sure you are using that feature to do your calculations. So you would take your pascals outside the parentheses, and again you set up your conversion using one of the conversions. In this case you could take pascals and your ATMs from our conversion sheet, and I do believe these will also be posted on the top of my website for easy access. And then the 2.75 ATMs would be your answer because your pascals canceled out in the problem. And you could also do the same conversion to go from pascals to torrs. For our last one, we're not going to worry about the PSIs. It's not something that we're going to use since we're not going to be meeting in class. Now, a little bit about air pressure. It's constantly present whenever air is present. It decreases with altitude. You might hear about there being less air at higher elevations, and it also will vary with weather conditions. It's typically measured using a barometer. Now, the old-fashioned mercury barometer had a dish of mercury, and the weight of the atmosphere would press down on the mercury. You would have a vacuum up here, and the amount of pressure that mercury could push up the column gave you your barometric pressure. Most of the time, though, we're trying to find the pressure of a trapped gas, and we do that using what's called a manometer. This is not a manometer, it's a manometer. Now, a manometer, at least an open-ended one, will have one end that's open to the atmosphere, and then you're typically trying to find the pressure of a confined gas. Now, if the atmospheric pressure is greater than the trapped gas, or in this case the gas pressure is less than the atmospheric pressure, you would take the pressure of the gas would equal whatever your air pressure is minus the height of the column. If your gas pressure inside here is greater than atmospheric pressure, you would take your atmospheric pressure, or P of air, plus whatever the H is. So looking at a few examples, for if we had 760 millimeters mercury as our atmospheric pressure and a height of 175, we would just add 760 plus 175. Well, that's not showing up. Just add those up to get your total pressure. Now, in the case of this one, your gas pressure is greater, so you would just take this number, and you would add them together. So, in the next few slides, you're going to see some practice with conversions and reading the values on a manometer. Please take some time and calculate those out. Make sure that you show your work in the spots provided for those answers.